Okay, so this is review for chapter 2. Look at the first one right here. Using this graph to determine the volume, right? So this is a graph, and then you want to look at the graph domain, and then find the function's range, and then x-intercept, y-intercept, all right? So one thing you can do here is you can make this graph a little bit bigger, all right, a little bit bigger in here. You can make it as big as possible, right? So I'm gonna make it pretty big. All right, so that should be enough to see a little bit clearly that way in here. All right. So first, if you read the grid right here, this is -5 to +5 right here. This is +5, right? And then this is -5. So this should be 0, and one grid is 1. Same thing as this one. This is 5, so this is -5. So each one is 1 in here. All right. So if I look at domain, so what does domain mean? Domain is the what? All the x value, okay? All the x value is considered a domain. All right, so the domain here, domain is all x value. All right, so what is my x value in this case? Well, this looks like this arrow means I can go up and up forever. All right, so that means I can have all the way from negative infinity to positive infinity. Look at that. This is connect, right? This one is connect in here. All right, so looks like this one is go all the way to the left and all the way to the right, and there's not discontinuous point anywhere in the graph. So that means the domain can be all real number, okay? And then the second one here is the range. So range is the y value in here, all right? And we do have a minimum right here, okay? So the minimum right here, you can see this is 1, 2, 3, all right? And that is from 3 to infinity because y can go up and up, all right? But y cannot move down. So this is the minimum value, okay? So that's your range in this case, all right? And we also look at the x and y intercept. All right, so what is the x-intercept? X-intercept, that means the graph passing the x-axis, right? And since this minimum value is 3, and it kept going up, it didn't come down. So that means this one do not have an x-intercept, all right? So x-intercept is none, or no x-intercept in this case, okay? How about the y-intercept? Yeah, we do see the graph passing the y-axis here, all right? So y-intercept here, if you write down the order pair is 0, x is 0, y will be 4 because this one is 5. So it's 0, 4. And sometimes it didn't just, if the question telling you type the integer, okay, if you just type in the integer here, it will be just 4. All right, if you just type in the integer here, it will be just 4, right? I think that's what the question asks. The y-intercept, okay, so look at this one right here. The find the y-intercept, and the y-intercept is type of integer. So that means this one did not ask you to type the order pair, okay? Only just need to type the integer, that is 4, all right? And then we also want to find this value f of the -2 and f of 1. All right, so what does that mean in here? That means we need to find f of, all right, so we will find the f of -2 and f of 1. So what does this one mean in here? This one means this is called a function notation, okay? We want to find the y value when x is -2. So this is x is -2. So if you look at this one right here, -1, -2 right here, right? So -2. Now we're gonna look at this one right here. This is -2. So corresponding to here, that looks like equal to 4 in here. All right, yeah, equal to 4. Okay, so f of the -2. So when x equal to -2, this is equal to 4. Okay, and then another one is f of the 1. F of the 1, that means we want to look at x value, x equal to 1, and how much is the y value. All right, so if you look at the 1 right here, corresponding y value should be 5. Okay, so f of the 1 is equal to 5. All right, so that is just reading the graph. All these questions here, all this information here are reading the graph, right? It's just reading the graph in here, but you will need to understand what does that mean in this case. All right, any questions? Okay, second one, we're gonna use the transformation of this graph to graphing the following. All right, so how do you do this type of question? One thing for sure is you can graphing, all right? But before the graphing, we also need to know some of the basic one, right? So look at this one right here. This is under the square root. Square root is called even root. Even root. Okay, even root, that means my everything under the root has to be greater than or equal to 0. All right, so we call this is radicand. The radicand has to be positive or at least 0, right? So if I go to graph this function, what happened in here? This will start with 0. Okay, start with 0, and it will look something like that. All right, so when this is 1, this is 1. Okay, square root of 1 is 1, and then when this is 4, okay, when this is 4, this should be around like a 2, right? Because the square root of 4 is 2. Okay, and then this will be going this way, increasing, but increasing slowly. All right, so that is y equal to square root of x. Look at that. Okay, and then I have h of x is x square root of x plus 5. So that means since under the root in here, so this is moving on the x direction. All right, moving on the x direction in here, and x plus 5 will also need to be greater than or equal to 0, right? And if you go to solve for x, this x will be greater than or equal to -5. Okay, so this one. All right, so this one right here is the same graph, but moving to the left for 5 units. Moving to the left for 5 units, so it will be something like that. All right, so this is h of x equal to square root of x plus 5. So moving to the left for 5 units. All right, so you can see this one is telling you, asking you to choose the graph, right? So this should be the right graph in here, because this is the only one moving to the left for 5 units. Okay, the rest is incorrect. This is moving up, this is moving down, this is moving to the right. Okay, so this moving to the left, that's the only one is correct answer. All right, so if you understand the graph, you can just do that right away. If you do not know the graphing per se, you can still put it in a calculator. Okay, so let me go ahead. Using the calculator, you will be able to graph this one easily. If using the graphing calculator, which we do allow you to use the graphing calculator for this course, for the test as well. So y equal to all right, let me clear all this one. Square root, right? So square root right here, square root is under the blue color. So if you want to hit a square root, you must have a second x squared. So you will get a square root, okay? And then you have an x in here, and then I hit enter, I hit graph. All right, so I have this one is y equal to square root of x, right? And if you want to look at the number in here, I can go to second graph, will be the table. Okay, so why this, when x is negative, why this all got an error? Because this is out of the domain, right? This is out of the domain. X should start from 0. Okay, so now you can see the graph for this domain here. X is starting from 0 in here. All right. And if I want to graph the second one right here, we're going to compare the second one. So second x squared is the square root, right? And then x plus 5. All right, make sure you cursor out and hit enter. And then we hit graph. All right, so this one is your h of x equal to square root of x plus 5. So you can see this one is moving to the left, right? Moving to the left for 5 units. And if I go to the second table, look at right here. When I have a x negative 5, right? My y2 is defined, okay? Because my y2 can start from negative 5. All right, but if you go a little bit left, well, this won't be defined. All right, when this is negative 6, this won't be defined anymore. All right, so that is one way to graph, okay? You can put it in a calculator and you can compare them, and you can find them in here. All right, so if I ask the domain, okay, if I ask the domain for this one right here will be from 0 to infinity, okay? Domain for the h of x, domain for h of the x, this will be from negative 5 to infinity. But the range is the same. This range is from 0 to infinity. This range is also from 0 to infinity, right? The y all start with 0 in here. All right, so range is the y value. Domain is the x value in here. So yes, that's the domain and range in this case. All right, any questions? So I'm giving you a little bit more concept in here just in case, okay? Okay, this is 2.6, okay? So what is on the 2.6? If you look at the 2.6 here, you will have this new operator, we call the operator, okay? This circle in here. All right, this circle is not a multiply, okay? So this one you will have to be very careful. I don't know how many of you got to 2.6. Did any one of you start a 2.6 in this case? Okay, I didn't hear anything. Maybe people are not get to the 2.6 yet, right? So let me go ahead, just open, because that one is called a composition. All right, so composition here, you will need to okay, so now let me see, I have a 2.6. All right, so composition, you have an inner and an outer function. All right, the first function is called outer, the second one is called inner function, okay? So that is the composition in here, okay? Let me see if we have any note. The algebra operation here is if you have a f plus g, you can just add the two functions together, right? And then when you have a f minus g of x, this is using the first one minus the second one. But make sure when you minus the second one, you have to have a parenthesis because the second one might have more than one item, okay? So be very careful. When you have a multiply, you can using the dot, solid dot, okay? This solid dot means multiply. If you do not write anything in here, fg, that means also means multiply, okay? F over g, that means division, right? You have a f of x on the numerator. G of x will be in the denominator. Given denominator cannot be 0, okay? That's a no, all right? So that is the multiplication algebra operation. What I'm trying to talk here is the composition. All right. So the composition here, this is a new one, new operator. Okay. F composite g of x is equal to f of g of x. So f will be the outer, g of x will be the inner. All right. And this is different than the multiply. Okay, so giving you an example in here. So if I have this one right here, f is the outer, g of x is inner. So this will be f of g of x. And sometimes, I just, for simplify, I just write down f of the g, right? So I don't have to put the x in here. So there's two ways to do this one, okay? Let me show you both ways. One way here is I plot g of x in. This is my g of x, right? G of x is x squared plus 6. So now g is gone, okay? G is gone. So this g is the inner. This is the inner, okay? And then this one is the outer. All right, so basically it's kind of I usually say the function is kind of like a machine, right? I have an x value, and then I'm going to this circle machine and going to this g function, and then come out will be g of x in here, right? And then I'm going to my triangle machine. All right, so this is f. All right, and then if I throw the g of x in, I will come out f of g of x, right? So this is the composition. So basically, go through the two function or two machine. Okay, two machine in here, and then that is how you come out f of g of x. Okay, so that is this way to look at the composition function. Like you're going through the two machine, but you have to go through the inner one first, and then come back to the outer one, and then we're gonna using the f function. So where's my f? F is 3x minus 4, right? And this x can be changed by anything inside the parentheses. All right. So I have a 3x minus 4, okay? So it's 3x minus 4, and this x here is the entire parenthesis, okay? It's x squared plus 6, and then I just calculate. So that's 3x squared plus 18 minus 4, right? And that's 3x squared plus 14. So that is f composite g of x function. All right, and if I have a g composite f, what happened? And that means g will be the outer, f will be the inner. All right, and I can plug the f in. So my f here is 3x minus 4, right? And then I'm going to use my g function. G is x squared. All right, so this x is the same as the parenthesis. So this is the square plus 6, okay? And what is the x squared? X is the parenthesis. So this parenthesis here is 3x minus 4. All right. And then you can go to get rid of this perfect square and then combine the like term. That will be the g composite f, right? And then this perfect square, you can go to do the FOIL, or you can go to do the perfect square formula. So the first term square will be 9x squared minus 2 times first and second term. So 2 times 6, 2 times 3 is 6, 6 times 4 is 24, okay? Plus 4 squared will be 16 plus 6. So this will be 9x squared minus 24x plus 22. So that will be g composite f, okay? So that is one way to do, all right? And what is the other way to do in here, okay? I'm just showing you the other way. Sometimes a little bit probably more intuitive, okay? So same thing, if I'm gonna just go from here, all right? Or I can just write down in here. F composite g of x, okay? So f will be outer, g will be the inner. All right, so I am going to my f directly, replace x with g, replace my x. All right, I'm going to the f, replace f with g. So you have a 3x minus 4, so I'm going to have a 3g minus 4 because my inside here is g, right? And how much is g? Well, g is x squared plus 6. So now I have a 3x squared plus 6 plus 4, okay? And then I can go to simplify this one. This is 3x squared plus this is minus 4. 3 times 6 is 18. 18 minus 4. So I got 3x squared plus 14. Look at it. You got exactly the same answer. Exactly the same answer here. Okay, so that's another way to do. I think sometimes people find the second way even a little bit easier. All right. So if I want to do the second way for the second one, what do? I have a G composite F, right? And then G will be the outer, F will be the inner. Okay, so now I go to the G directly, replace the X by F. Okay, so this one you only replace, X by F seems very easy, right? So now this will be F squared plus 6. Look at it, because G of X is X squared plus 6. So I have a F squared plus 6. And then how much is my F? Oh, my F here is 3x minus 4. And I'll go to get this one. So these two are the same. Look at it. These two are the same. Okay, and then you go to do the same calculation. So that is the second way you can do the composition in here. All right. Now let's come back to do this one. Okay, this is a new operator. So yeah, we learn the addition, subtraction, multiplication, division, right? We also learn the square root, right? And then we also learn the square, something like that, right? Now we have a new operator, this one right here. This is only applied to the function, okay? Only applied to the functions, all right? And this one is not multiply. This one is called composition, okay? This is called composition function. All right. So using the layer, the first one is the outer layer. The second one is the inner layer. All right. So let's go ahead do this one right here. Number 3, we have a f of x equal to 7x. G of x is x plus 7, right? And I want to find the A here is F composite G of x. All right, and we said that earlier F will be the outer, G will be the inner. Okay, so I'm going to do this way, do the second way, probably even easier. So I'm going to my F function replace x, replace this x by G. All right, so this will become 7G. Okay, and then eventually I plug the G in. So 7G is x plus 7. So this whole thing will be 7x plus 49. And it's done. Okay, and if I want to do the C, okay, I'm going to go ahead and jump into the C. If I want to calculate F composite G of 4, I just need to replace the x by 4. And it's all done. I can using this function. So that should be 7 times 4 plus 49. Look at it. So it's very easy when you have this function already, right? So that's 28 plus 49. So that should be 77. Something like that, right? So that is giving you the composition. Okay, now we're gonna come back to B here. So B here is G composite F. Okay, G composite F. G will be the outer, F will be the inner. So this time I'm going to throw the F into G. Throw the F into G, right? So if I go to G directly in here, replace the X by F. All right, so this will be F plus 7. Instead of x plus 7, I'm going to have f plus 7. And how much is my f? Well, my f here is right here. My f here is 7x. So this will be 7x plus 7. And that's it. All right. There's no like item you need to combine. So that's G composite what? G composite F. Okay. And if I want to find my D here, G composite F when x equal to 4, right? So when x equal to 4, you already find a composition function. So you just need to replace x by 4 in. All right, so that should be really easy to calculate in here. All right, So that will be 35. Okay, so that is the composition. Yeah, this is a new operator. Okay, a new operator. And that is probably the only new one for this chapter, right? You all knowing the addition, subtraction, multiplication, division already, and then this is called a composition. All right. Any questions? Let me check the chat to see anyone has any questions. Okay, I don't see any post any question. All right, number 4. This is the inverse function. Okay, this is 2.7. This one is considered the inverse function. Okay, giving you f of x equal to 7x minus 6. How do you find the inverse? Okay, so what does the inverse mean? Inverse means you switch the x and y. All right. Okay, so number 4, finding the inverse. All right, we have f of x equal to 7x minus 6. This one is considered the inverse function. Inverse function. All right, so in order to have an inverse function here, you have to have a 1-to-1 relationship. So what is 1-to-1 relationship? So that means 1x can only have a 1y. 1y can only have a 1x. So sometimes we just write down like that, 2L. All right. So what does this one mean in here? This means 1-to-1 function, right? 1x can only have a 1y. 1y can also have a 1x. So if you have a 1x only have a 1y, this is called pass a vertical line test. And then 1y have only 1x, this is called pass the horizontal line test. Okay. So if you look at this kind of function right here, this one is a function because it does pass the vertical line test, right? If you drop a vertical line, it only pass 1 point. Okay, for the graph only pass 1 point. So that one is a function. But this one didn't pass the horizontal line because if I drop the horizontal line right here, this is gonna cross 2 points. Okay, so this one is called a horizontal line, past 2 points. So this one is a function, but not a 1-to-1 function. Okay, so how do I get it to be a 1-to-1 function? If I put it this part, okay, if I only have a partial like that, all right, now have a left hand side. If I restrict the domain here, only have a x is greater than or equal to 0, right? X is greater than or equal to 0. Now this one will pass the vertical line, right? You pass the vertical line and also pass the horizontal line. So this one will be a 1-to-1 function. Okay, so in order to find the inverse, you have to have a 1-to-1 function in here. And if you go to graph y equal to 7x minus 6, right? How does this one look like? This will look like that. This will be 0. This will be negative 6. All right. So this will be y equal to 7x minus 6. And this one, it does pass the vertical line, right? Pass the vertical line because you drop a vertical line anywhere, it only pass 1 point. And of course, this one also passes the horizontal line, right? If I drop anywhere, it's only pass 1 point. So yeah, this one is 1-to-1. So 1-to-1, you can find the inverse. All right, so what does the inverse mean? Inverse basically is to switch x and y. All right, so for example, if I have this point is 0 and 2, okay? And this is on my y-axis. And what is my inverse? My inverse is switch the x and y. So this point here will be 2 and 0. So these 2 points, point A and point B, consider inverse each other. because I switch the x and y. X become y, y become x. So that's the character for the inverse. Switch the x and y, right? All right, so now we not only just want to find a point, we actually want to find the entire function, okay? Want to find the entire function inverse. How do we do that? Well, step one, okay, this one you can follow the step easily. Step one, you write down y equal to 7 minus x. So replace y with f of x. Okay, instead of using the f of x, you using y. So replace y with f of x. All right, second step is the most important one. We need to exchange x and y. Or sometimes we can just say switch the x and y. Okay, so what does that mean? The y gonna become x gonna become y. All right, so look at it, y become x become y, and the rest is exactly the same. All right, so that is consider the inverse, and then we're gonna solve for this new y. Okay, I usually call it a new y because this y is different than the previous one. So this is your new y. We're gonna solve for this y. All right, so how do I solve for y in here? I need to isolate the y, right? So we're gonna add a 6 on both sides, So this will be x plus 6, and then these two cancel out, equal to 7y. Divide both sides by 7. So now I have a y equal to x plus 6 over 7. And then I just write down this one into a function notation. So this new y is my inverse function of the x. So my inverse here will be x plus 6 over 7. That's my inverse function. Okay. If I graph the original function and my inverse function, let's see what does that look like. Okay, we have a 7x minus 6. All right, if I graph this one right here, I have my y1 is 7x minus 6, right? So you have a x-intercept right here, and then you have a you have a y-intercept right here, you have x-intercept right here, right? And I graph my y2 here. So what is my y2, which is my inverse? My inverse here is x plus 6 over 7. Okay, so if I graph this one right here, that is my inverse. Okay, so look at this one right here. I have this x-intercept. Now I have this one become the y-intercept right here, right? I have this y-intercept right here, like a negative 6. Now I have become an x-intercept here is negative 6 in here. Okay, so these two are exactly switch the x and y, the inverse each other. There's one more character here is if I graph y equal to x, and this y equal to x is exactly in the middle. All right, so that means the original function and the inverse function, they are symmetry along the line y equal to x. Symmetry along this line. All right, so that is how you find the inverse if you just follow these 3 steps in here, or actually 4 steps, right? After you solve this new y, you have to write down the inverse notation, okay? So step 1, you replace y using y for the f of x, right? And then the second step is the most important one. You need to switch the x and y become x become y. And then you solve for this new y. So that means you need to isolate y by itself in here. And that is the inverse function, okay? And you write down the f of the inverse in here. All right, so that is how we find the inverse function in here. And then what is the graph? Okay, so, oh, that's different one. Okay, so let's see what I ask in here. Oh, there's a graph right here, right? So the first one right here, you need to find the inverse function, and the second one, you want to choose the correct graph. All right, so let's see which graph will match. The original one is the blue one, right? So the blue one and this one right here. So this looks like the right one. The rest looks wrong that way. Okay, that's the correct one. In this case. All right. Um, the second one here is the number C here. We already found it, right? C here is state the domain and range for the f of x using the interval notation. And we also need to find the domain for the inverse notation and the range for the inverse notation, right? Since this one right here, the blue one, if you look at the blue one right here, x is all real number, and this is a straight line, right? Y will be also all real number, okay? And the inverse is also a straight line, all right? So when I have an inverse, that's my inverse is also straight line. There's no x in the denominator or under the square root. So this inverse domain and range is also all real number, okay? Because sometimes the inverse and the original one, they switch the x and y, they also switch the domain and range. So that means the original domain gonna become the range in the inverse, something like that. Okay, but since these both are all real numbers, so they switch, they still all real number. All right. So 6 and 7, I think those two sections are relatively new, right? One is the composition, one is finding the inverse notation. Any question? I want to give you a little bit time to see anyone has any questions. Okay, number 5, this one is we do not know what is the f of x expression, but it giving you the graph. Okay, so you're gonna using this graph and then to to regraph g of x. G of x is equal to f of x minus 2. So now you have to know how to read this function. This is inside the parenthesis, so that means the g of x is f of x moving on the x direction. All right, so moving on the x direction. So minus 2 actually is moving to the right for 2 units. Okay, f of x minus 2 is moving to the right for 2 units. So now, how do you know this graph moving to the right? How do you calculate? How do you? I would usually say choose a hue point. Okay, this didn't move vertically, only move horizontally. All right, so if you see anything move vertically, it's wrong. Like say this one, this you have this one, right here. This one move vertically, so that's wrong, right? That kind of thing. This one also move vertically, so that is wrong. Okay, so you can see like which one moving horizontally, which one moving vertically. So this one is wrong, this one is wrong. B and C both move vertically, so that's wrong, right? So the only possible answer here is either A or D, okay? Because A or D looks like a moving horizontally only. And this is moving to the right, okay? If you have make x minus 2 equal to 0, x will be equal to 2. So this is moving to the right. All right, so which one is moving to the right? You can go to look at this like an origin here, right? And then this moving to the right for 2 units, so should be right here. So should be right here. And then if you look at this point, this is moving to the left. All right, so A should be the correct answer because that's the only one moving to the right. Okay, This one you cannot really using the calculator because there's no function for you to graph in the calculator. So this is basically just reading the graph, okay? Using the graph, and then you just need to know this one is moving on the x direction to the right for 2 units. Okay, number 6, you want to determine the function is an even or odd function, and then which one is symmetry to what? All right, so that's a little bit character for this chapter in here. First, before you do this one right here, you have to know what is an even and what is an odd function. All right. In order to be an even function, you have a f of negative x will equal to f of x. That means if you replace x by negative x, and it still come out the same. All right, and this one is symmetric with the y-axis. Okay, so for example, like you have this one right here. This will be the y equal to x squared will be the even. Will be the even function because this one it is symmetric with the y-axis, okay? And if I plug if I have a f of x equal to x squared, right? If I change this x into negative x, this will be negative x squared, and this is still negative squared, still positive, so it's still equal to x squared, still equal to f of x. So that means I prove this relationship is satisfied. So that means this one is even. All right. So what kind of function will be odd? If you can go to proof f of the negative x is exactly equal to negative f of x, that will be an odd function. All right. So that means I plug the f of x, I replace the x with negative x, and then it comes out exactly the opposite of the original one, and that is an odd function. The odd function is symmetric with the origin. All right. So like this kind of graphing, okay, symmetric with the origin in here, and that will be the odd function. Okay, giving you this concept, so now we're gonna come back to do this one right here, right? According to this concept in here, I'm going to calculate my f of negative x, okay? So f of negative x. Replace x by negative x. So this will be 1 over 5 negative x to the 6 minus 3 times negative x to the 4. All right, since this negative with the even power, so it will still positive. All right, negative to the even power still positive. All right, so even I replace the f of negative x, this whole thing still equal to f of x. Is that right? Equal to the original one. So that means I prove f of negative x equal to f of x. So this one will be an even function. All right, so that is how you prove the even function in here. Okay, and since this even function is symmetric with the y-axis. Okay, number 7 is another reading graph. Okay, another reading graph in here. So how do we read this graph? This one is f of x, right? And then g of x is gonna be equal to f of x plus 4 parentheses and then plus 6. One thing is on the y-axis is easier. This plus 6 is outside the function. So that means this one is moving vertically, moving on the y-axis. On the y-axis, when it's positive, that means move up. When it's negative, means move down. On the x direction, it's just exact opposite. Okay, so this one is x plus 4 here. This one actually is moving to the left for 4 units. All right, so now we're gonna go to look at this graph moving up for 6 units and also moving down for 4 units. So which one will be that way? Or you can see this one is moving down, this one is moving down. So B and C is incorrect already. So look at the vertical one, it's very easy to identify, right? Now the only possible answer here is either A or D in here. Okay, they both move up for 6 units. They both move up. All right, and they have to move for 4 units, and these 4 units should be moving to the left. All right, if you look at this one right here, this is moving to the right. Okay, if this point right here move up here and then moving to the right, so that's the only correct answer. This move up and also moving left 4 units. All right, any questions? Okay, number 8, you want to give you these 2 points in here. You want to write the equation in a point slope form or write down in a slope intercept form. Okay, so what do you need to do in here? Well, the first thing here is for sure you have to find the slope. Okay, and if we're using y minus y1 equal to m times x minus x1, this one is considered a point slope form. All right, if you go to write down y equal to mx plus b, if you use this one right here, this is called slope intercept form. All right, so you have 2 different forms in here, but either one of us, you have to find a slope of m. Okay, so m here will be y2 minus y1 over x2 minus x1, right? So I have a -4, 13, I have a 1 and -2. I can mark this one is x1, y1, or I can do the other way. Okay, I usually like a small number as the first one. Okay, so we can make it. It doesn't matter which one you make it x1, y1. All right. I'm gonna have this one is x1, y1, x2, y2. The reason I recommend to write down this one right here, so when you plug in, it's much easier, right? So y2 will be 13 minus y1 here will be -2. x2 here will be -4 minus x1 will be 1. All right, so this will be -5. 13, this negative become positive 2. All right, so now I have a 15 over -5, or this will be -3. So -3 here is my what? Slope. Okay, negative here is my slope. And then I have this one right here. So if I want to write down in a slope point form, I will have a y minus y1, okay, equal to m times x minus x1, right? So that's my, or I can just write down this one is plus 2 equal to -3x, and then this will be plus 3. All right, so that is my slope point form. If I want to write down a slope intercept, I will just write down y, -3x and -2 on both sides. Okay, and then this will be cancelled out, and then this will be plus 1. All right, so that is my final answer for the slope intercept form. Okay, so in this case, you just need to be able to find a slope and then plug it in. All right, this one you want to give you a little bit value, find the y and f of x and g of x when x equal to 0, 1, 4, and 9, right? So when x is 0, you will need to plug this one in here. This will be 0, okay? And then g here, this will be 0 minus 5, so this will be -5, right? So we can give you a little bit of number 9 x value. Okay, x is 0, and then we're gonna have a f of x equal to square root of x, right? And then we have a g of x is equal to square root of x minus 5. So when x is 0, square root of 0 will be 0, right? And then this will be 0 minus 5 or negative 5, okay? And then when x equal to 1, when x equal to 4, when x equal to 9. All right, so if you calculate this one right here, square root of 1 will be 1, 4 square root will be 2, 9 square root will be 3, right? And then this one, you just minus 5. So minus 5, 1 minus 5, that's negative 4, right? And then 2 minus 5, that's negative 3. And then that will be 3 minus negative 5, that's negative 2. All right, so that is how you calculate this one in here. And then finally, you can put it in a calculator graph them to see how you look at that, right? As we mentioned earlier, this is y equal to f of x look like, right? This is y equal to f of x, or f. And then you have another one is moving down for 5 units. All right, so if I have a negative 5 right here, this is moving down. So this will be g of x, moving down for 5 units. All right, and then you just go to pick your correct graph, right? So correct graph moving down for 5 units. So this one is moved up, so that's wrong, right? So this is the only one moving down that way. Questions? All right, number 10, you want to find a domain for the function. Okay, so I want to emphasize here is domain, you just have a 2 requirement. All right, when you have one is called NO, this is a no, right? So when you have a 2 over x minus 1, right? If I have a y equal to 2 over x minus 1, x minus 1 cannot be equal to 0, or x cannot be equal to 1 if you go to solve x. So that's your domain, okay? But this one right here, when you have a square root, g of x is equal to square root 4x minus 60. This square root is considered an even root. Even root, everything inside the root has to be greater than or equal to 0. That means it cannot be negative. When it's R root, can be anything. R root can be all real number. All right. If I have y equal to q root of x, this q root will be something like that. All right. So y equal to q root of x. This q root can go anywhere. All right. So domain is all real number. But the even root, you can't. Even root, have to make sure everything inside the even root has to be greater than or equal to 0. And then we go to solve x, okay? We add a 60 on both sides, all right? And then we divide by 4. So x will be greater than or equal to 15, right? So 15, greater than or equal to 15 is going to the right. All right, interval notation will be from 15 to infinity because it has an equal sign. So you use the bracket with the equal sign. All right, so that is how you find a domain, okay? This domain is very important. When we talk about function, we always have to deal with the domain. Function is kind of like a machine, right? Domain is kind of like the material. What kind of material can you throw into the machine so you won't break the machine that way? All right, so that's the domain. And then you only have 2 rules. One rule is denominator cannot be 0. Another one is even root. Even root, everything under the root cannot be negative or have to be greater than or equal to 0. And you go to solve that. All right. Okay, let's see. Number 11. In here, we need to find a inverse, right? This f of the negative 1 is not like this is considered the inverse notation. Okay, so how do we find the inverse notation? We talked earlier. If you remember the step we have earlier, right? step 1, we're gonna write down y for the f of x. So this will be y equal to x cubed minus 5, right? And then switch x and y become x become y. All right, and then we're gonna go to solve for this y, solve for y. So how do I solve for y here? Well, I have to get rid of this 5, so I need to add a 5 on both sides, right? So this cancel out. Okay, so this will be x plus 5. So now I have a y cubed equal to x plus 5. How do I solve for y here? Well, if you want to have a 1y, you need to take a Q loop on both sides. Take a Q loop on both sides. So this Q loop and Q will cancel out. So you will get a y equal to Q loop of x plus 5, right? And then we write down this one is the inverse. So my f of x, the inverse will be Q loop of x plus 5. Okay, so that is the Q loop in here. And you can go to do the graphing, okay? Graphing, we remember the Q loop and the original function is supposed to be symmetric with y equal to x. So if you go to graph this Q loop, okay, I'm not using a calculator, so a little bit more precise. All right, so we have a y equal to x cubed minus 5. Okay, so that's y, the blue one is y equal to x cubed minus 5, right? And then we're gonna go to graph the inverse. The inverse here is Q loop, so you can go to math here, you can find the Q loop in here, all right? If you don't have this Q loop, you can just write down as 1/3 power, okay? All right, so Q loop of x plus 5. All right, so this one is under the loop, but this is R loop. So R loop domain basically can be anything. All right, so this domain, only the even loop has to be greater than or equal to 0, but this is Q loop. Q is 3. It's R loop, so domain can be all real number. Okay, so you can see that is switch the x and y. You can see this is y-intercept. Now this become the x-intercept in here. This is -5, I guess, right? 1, 2, 3, 4, 5. Yeah, this is -5 for the y-intercept. Now you have a -5 for the x-intercept in here. So that exactly switch the x and y. All right. If you want to look at their table in here, you can see, yeah, they switch the x and y in here. Okay. The y1 and y2 in here. All right, so now you can just go to match this graph, right? So if you have this graph here, you can just go to match the correct one, okay? So the correct one, the only correct one looks like the correct, it looks like the B, right? If you match this graph, okay? So that is right here. All right, and then you want to find let's see what you want to find the domain and range. You can see that from the graph, right? The domain and range is, since this is the first one here is the qubit. So the qubit here, domain and range is all real number, right? And then you have a Q loop here. Q loop here is also can be all real numbers. So the original function and the inverse function, domain and range, they are all real number in here. Okay. All right. So by now you should be very familiar to see how you find the inverse. Okay, this one giving you another practice of finding the composition, right? If you remember how to find a composition earlier, this will be a really quick review in here, all right? So you have a f of x equal to x plus 4. G of x is 4x plus 1, right? The a here, you want to find the f composite g of x. All right, so that means the f is the outer, g is the inner. Okay, so if you want to have one step, go to the f, change x into g. So this will be g plus 4, right? This one you have x plus 4. In here, change x into g, so that's g plus 4. And how much is a g? Well, g is 4x. 4x plus 1, and then plus 4. Or 4x plus 5, the final answer, right? And then if you want to find a c here, f composite g on x equal to 1, right? So you just come back to this function, replace the x by 1 here, and you got an answer. Okay, so this will be equal to 9. Same thing as b, all right? So when I have a b here, g will be the outer, f will be the inner, right? So that's g of f. All right, I'm giving you the shortcut here already. So go to the g function directly, replace the x by f. So this will be 4f plus 1. All right, and then go back to f. So 4 times f plus 1. All right, so my f here is x plus 4. Okay, and then we just simplify 4x plus 16 plus 1, so that will be 4x plus 17. All right, so that's the composition. And then we can go to find the d here is when g composite f when x equal to 1. Right now you can just come back here, replace x by 1 here, so that will be 21. Okay, so that's how you can calculate this one right here. So eventually the composition become not that bad, right? Any questions? I didn't hear any question. I want to see if anyone has any questions. Okay, no one checked anything. Okay, 2 or 3 more questions. Okay, number 13 here. This one is another reading the graph. Okay, so whatever that function is, but this is the graph. It didn't give you the f of x, but it does give you the graph, right? So what is the domain? Domain is all the x values. So what does the arrow mean? This arrow, that means it can go on and on forever. All right, so that means it can indefinitely extend to the downside in here. All right, so domain is all the x values. So looks like that x can be anything, right? X can be all real number because this can go on and on, that one. All right, x can be all real number, but the y cannot. Y, this is your maximum, right? This, if you look at the y value here, this is your max. And what is the bottom one? Bottom one can go all the way to negative infinity. Okay, so if you look at this one here is 5. So my range here should be from okay, so my 13 here. Oh, my 13 here, domain x can be all real number. Okay, the range y here should be less than or equal to 1. Okay, that's 1, 2, 3, less than or equal to 1. But if you want to write down in an interval notation, so how do you write down the interval notation? This will be from negative infinity to 1. All right, interval, you always write down a smaller number on the left, large number on the right. Okay, so that's something you will need to be careful. And then we're gonna find the x-intercept. Oh yeah, we do have a 2 x-intercept here. All right, so if we asking you the x-intercept here, this one will be from -1, and then another one will be +1, right? So you only need to write down the -1, common 1, and that's it. You don't have to write down the order pair because it's only asking you the x-intercept value. Okay, similar to the y-intercept value. All right, we do have a y-intercept here. So this y-intercept, that is y is 1. Okay, so just write down 1 in here. That's all. All right. Okay, we also need to read a graph f of the -2 and f of the 2. All right, so let's see, where's my f of the -2. Okay, so when x equal to -2, right, you can see this one here is -1, -2 should be right here. So if you look at the -2 here, this should be like a -3 because this one is -5. So this should be -3. And same thing, f of the +2 here, right? +2 here, this is also -3. Okay, so that's just reading the graph and then answer the question. All right, this one is kind of like a repeat to the question we have earlier, right? This kind of question here is you need to find a slope and then write down the equation, okay? So very similar to the one we have earlier. So I have a 1 and 2, 8, and 16, right? We can say this one is x1, y1, this is x2, y2. So my m here will be y2 minus y1 over x2 minus x1. So that's 16 minus 2, 8 minus 1, right? So that's 14 over 7. Oh, my slope will be just 2. Okay, and the point slope formula is y minus y1 equal to m times x minus x1, right? So I have a y minus 2 equal to 2 times x minus this one. Some people say, I want to use this one as x1, y1. That's totally fine, okay? If you use this one as x1, y1, this one will be x2, y2. All right, so that's your point slope formula, right? And then if you want to find the slope intercept formula, that means you need to write down y equal to mx plus b4. So that would be your A, right? And then B here, if you want to write down a slope intercept. Actually, you don't have to go to find a B. You just need to organize this equation, make it to this formula. All right? So we're going to y minus 2, multiply this one in, 2x minus 2, right? And then we just add a 2 on both sides. All right? So this y will be just 2x because these 2 cancel out. So this so some people ask how much is my b? My b here is 0. All right, I don't have to write down 0. Okay, so b here is 0. So that's just y equal to 2x. All right, so that is a repeat, similar to the previous one, right? Okay, number 15 here, this is in a random order, right? So actually this one is from the fourth section. If given you this function f of x equal to x squared minus 3x plus 1, can you evaluate all these three? The answer will be yes, right? Of course, we can evaluate all of them in here. So you just replace x. Okay, I have my f of x is equal to x squared minus 3x plus 1. So replace x by -5. So this will be -5 squared 3 times -5 plus 1. Make sure -5 need to be in a parenthesis because this x is equal to -5. So -5 squared will be positive. Okay, and then this negative times negative will be positive. So that's 40, 41 that way. Okay, so that should be easy calculate. I'm going to do the C since the C is a little bit easier, and then we're going to come back to do the B. So how much is my f of -x? Well, that means I replace x by -x. Look at that, replace x by -x. And then -x squared still positive. And then this negative become positive. All right, so That is this one right here. So you can see this one, I'm gonna combine the even and odd function earlier together, okay? This one f of x is not equal to f of x. Look at it. Because this one f of x is minus 3x. I have this one is plus 3x. So that means this one is not an even function. Okay? This one is not an even function in here. And sometimes people will say, is this an odd function? Well, odd function, you have to go to find the f of negative x. We have a f of negative x in here. You have to find opposite of f of x, and then the negative f of x, this will be negative times the entire f of x. So it will be x squared minus 3x plus 1. Get rid of parentheses. This will be negative x squared plus 3x minus 1, right? And is f of negative x equal to negative f of x? Are these two equal? Okay, we have this one right here, and then we have this one right here. Apparently, they are not equal. They are not equal. So what does that mean in here? That means this is not R either. Okay, so that means this function is neither. All right, it's not an even, not an R function. That means it's not symmetric with the Y, it's not symmetric with the origin. Okay, so some of the function in here will be not even, not R function. So you just need to go to proof their relationship that way. Okay, so that is a little bit extra for this question. Okay, even it didn't ask, I'm just giving you a little bit more review for the even and odd function in this case. All right. Okay, let's go to do the last one here, which is B. Okay, B here, it's just calculation, right? We just need to calculate f of x plus 7. So that means we will replace this x by the parentheses. Look at it. All the x is going to be replaced by the parentheses. So this will be parentheses square minus 3 times the parentheses plus 1. Okay, according to this pattern. All right, and what is my parentheses? My parentheses here is x plus 7. X plus 7, right? And then we just get rid of this perfect square, and then you can FOIL it in. I'm going to use the formula, right? So that first term square plus 2 times the first term times the second term. So that's 14x plus the second term square. 7 square is 49. Get rid of this parenthesis. So that's 3x minus 21, right? Make sure you distribute to the second one with the negative 3 plus 1. Okay, and then these two are the like term. All right, so we're gonna plus 11 minus 3, 14 minus 3 will be 11x, right? And then combine all these 3 together. Okay, so 49, this 21 plus negative 21 plus 1 will be minus 20, right? And then this will be 29. All right, so that will be the whole thing in here, how you do the calculation. Okay, you just have to be very careful, calculate, right? All right, so that's all we have. We already given you the review for this entire chapter. I really strongly recommend you to review this very carefully, because this is a text review basically. I don't really test you anything beyond this content here. Okay, I'm gonna stop the recording before I